the cross-section of a trough that is L meters long. Okay, let's put some information on here. L meters, where's that? That's the trough, it's L meters long. The cross-section is in the shape of an isosceles triangle of base measurement 2A meters. Whoops, sorry. And, where did I lose my page? Height B meters. Okay, so we've got this measurement. Find the rate at which the water level is, sorry, I missed the sentence. Water leaks from the trough at a constant rate of C meters cubed per minute. Okay, there you go. Now I have a diagram. Find the rate at which the water level is falling when the depth of the water is B on 2 meters. Okay, great. So there's your little setup. Now, this is not something I did in previous questions, but in a question like this, it's going to be very helpful to us. Everything that I've just said, the question is just provided to us, right? How many of them can change? How many of these quantities can change? I've drawn 4 on there. How many of them can change? My answer is none of them can change. None of these ones can change. Anyway, because what are they? They describe the physical dimensions of this trough, and we're not expecting it's a magical trough that can just, change its shape. It's a shape-shifting trough. It's not one of those. It's just going to stay those dimensions. And you've got this water leaking out here, but that's constant. None of these things are variables, okay? So therefore, I'm actually just going to, on the top right-hand corner of where I'm doing my working, I'm going to label those as constants. Now, in previous questions we haven't done this, partly because there just haven't been that many constants flying around. For instance, they'll give you a number. They'll say it's 10 meters long, and they'll say it's this wide and that tall, and we don't need to usually think, oh, is 10 a constant or a variable? You know it's a constant, right? Here, they have all these pronumerals, and it can be very easy to confuse which ones are actually, sorry, did I just say? There's lots of pronumerals, is that right? Some of them are going to be variables, but these ones are going to be constant. So I'm going to take note of that, okay? I've got an A, a B, a C, and what was it? L. There you go. Okay, great. Now, what was the question? Find the rate at which the water level is falling when the depth of water is B on 2 meters. Okay, now, there's something that's changing here, right? But all of these things are constant. So I'm going to introduce some language here. I need to introduce some variables, right? So let me put some water in this. Ta-da, I have water, okay? Let's make it a transparent trough, shall we? We've got some water going along there. You get the idea. Okay, so there's some water in there. That water is going to have a volume, it's going to have a depth, right? So let's start to talk about that kind of stuff. Let's say, let V be the water volume. Now they talk about depth, but I try as much as I can, even though it's not always possible, I try as much as I can to avoid having a variable called lowercase d, because then you get dd on whatever. Okay, now, honestly, it's going to happen to you sometimes, okay? So you can't always avoid it. Sometimes they say, let this equal d, and you say, jerks, okay? But let's try and avoid it. So instead of talking about depth, I've got water volume. Let's talk about height, shall we? H be the water height, or depth. They're the same thing in this context, okay? Let V be the water volume, H be the water height after, and I want a time variable in here, right? Because these two things, unlike these guys, these two are changing, right? So after t, now, what unit should we choose for time? Let's go with the same one that they give us, right? You won't always have that luxury. Sometimes the units in time are going to mix up and you have to be very, very cautious about these. But thankfully, the only thing that's dependent on time right here is the water leaking. They provided a unit, so we might as well stick with that, okay? Good. Now, having just introduced all of these, in the same vein as I did this, I'm going to say variables. And I said V, H, T. volume, height, time. Great. Now, having phrased the question in this language, okay, what is it that I'm actually trying to find now? I'll read the question again. Find the rate at which the water level is falling when the depth of water is beyond 2. So, what expression, or what equation am I trying to solve? What am I looking for? The rate at which the water level is falling. How would you write that? That would be dh, the change in the height, over time. It's going to be some, it's all meters, isn't it? It's going to be some meters per minute, okay? Now, therefore, if I want, right, this is what I want, okay, dh on dt, I'm going to need to put that in terms of the other information that I have, okay? Well, there's another rate in here which we've been given, right? What rate from this diagram do we know? We know the constant c, don't we? Water is leaking at c cubic meters per minute, okay? So therefore I can make a statement about what derivative? dv on dt. Is it getting bigger or is it getting smaller? It's reducing, isn't it? Because water's coming out, okay? So therefore it should be negative, it's decreasing, and it's just equal to that constant, negative c, okay? Now, it's nice to have dv on dt, because that means we have something on dt here, right? So therefore, when I'm trying to find this, I'm going to use chain rule, aren't I? What should I write over here on the right-hand side? I want to write, I suppose you could write it in whatever order you like, because it's a product, isn't it? But I tend to like having the thing on the top first. I want a dh on the top, right? And I already know I've got dv on dt down the bottom, okay? So clearly, I'm going to need this derivative here. Okay, so if I can solve for dh on dv or dv on dh, which is really the same thing upside down, then I'm basically sorted. Does that make sense? Okay, now, therefore, to try and work out this, I will need a relationship between v and h. A relationship between v and h, okay? So maybe I should put h on my diagram. There it is, okay? So how will I form a relationship between v and h so that I can differentiate it? A relationship means again, what I want, right? So well, I'm trying to say I want this, and that's why I write this. I want v, right, as a function of h. Does that make sense? And then I can differentiate, yeah? What would v be as a function of right now? What do I need to work out the volume of the water in the tank, right? Trough, sorry, okay. Well, I need height, but there's another measurement I need, isn't there? I need to know the base. It'd be a bit funny calling it a base because it's upside down, but I need this measurement here. Here. Right, the width of the surface of the water, okay? How will I get that value, okay? Now, just like in the previous question with the shadow, okay, I've got some similar triangles happening here, right? So let's call that horizontal distance just temporarily. Let's call that x, okay? What kind of expression, what kind of equation can I write that relates all of these things together in similar triangles? What would you put down? Yeah, okay, I'm going to go, I suppose you could write it a couple of different ways. I'm going to connect the ratio of the sides in the small triangle with the ratio of the sides in the big triangle. Is that okay? So I'm going to have little base on little height, right? Should equal big base on big height. Is that okay? I haven't done anything too dramatic here. Okay. Now, by the way, this is a rates question. It's a calculus question. I'm not going to bother too much with the proof of similarity. I'm just going to state that. Okay. Right. Fine. Now, from this equation, what way should I rearrange it to make things helpful for you? Because I could rearrange it in a variety of ways, couldn't I? Should I make h the subject or x the subject? Because I can choose. I'm going to make x the subject, partly because, I mean, I did write it that way. I could have written it upside down, right? But the reason why making x the subject is useful is because that h is going to be there. I actually want to get rid of x, don't I? Right? When I have this expression for volume, I only want it to be in terms of h's, right? So ordinarily a volume will have x and h in it, but now this line will let me get rid of the x's. Okay, so watch. Now that I know this, I can say volume is, well, the volume of a prism is cross-section times depth or length, right? So what's the cross-section here? It's a triangle. That's half times base. What did we just establish the base was? This. Times height. That's that isosceles triangle. That's the cross-section there. Okay, maybe I'll even write that. That's the cross-section. Okay. And then I just have to know how long the thing is, which conveniently is just L. Okay, so let's just tidy this thing up. I'm going to write it like this. 2's cancel. Okay. I know it's not alphabetical, but can anyone see why? Why have I put my L's before my H's? Why would I write it in this way and not have the H's on the fraction? Number one, I'm going to differentiate, right? So this will make it a bit easier for me to see. Number two, I'm trying to distinguish between the fact that not all pronumerals are created equal. A and L are constants. We always put constants out the front, don't we, right? B, sorry, is also a constant, right? Whereas H is the variable that I'm after. Of course, you don't have to write it like that, but really I'm trying to make things as clear as I possibly can. Okay. Good, so now I have volume as a function of H. That's what I was after. So why was I after that again? So I could differentiate. That's right, so that I can get this guy. Okay, so I'm climbing back up the ladder, if that makes sense. So I can work out dV on dH on this basis, right? It's just a power, so I bring the 2 down. 2AL on B, and the power reduces by 1. Cool. So now, am I ready? Can I stick this into the actual original line that I wanted? I think I can, right? Therefore, dH on dt is equal to, this is upside down. I don't want this. I want its reciprocal, so I'll flip it. That gives me B on 2AL. Unfortunately, I can't keep the H out the side anymore because it has to go in the denominator, times, what's my dV on dt? It's negative C, isn't it? I already established that. So I've got this. Okay? Now, this is how the depth of the water is changing given any particular height, but I don't want any height, I want a specific one, namely when it is B on 2. Okay. So I'll say when H equals B on 2, I'll sub it in. And it looks like I get, now let's see, this B will cancel with this B, and this 2 will cancel with this 2, yeah? So I'm left with minus C on AL. Is that right? Everything else is gone, isn't it? Okay. So am I finished? I'm ever so close. I've done all the work, haven't I? Okay. But what does the question say? It says, find the rate at which the water level is falling. Now, you know all of this stuff, we introduced all of this stuff, right? So when I say this, dH on dt, the question has no idea what dH on dt is, right? It could just as easily have been, what's H? Who knows? The question didn't specify that, right? They're all constructs that I've made up because they're convenient for me so I can work with it, okay? I need to provide the answer back in terms of what the question was asking, okay? Now that's two things I've got to notice. Number one, I've got units, which I've left off because derivatives don't have units on them, okay? So I should say, therefore, the, what's the wording? The water level is falling at, now the first thing I said was units, right? But the second thing that I have to account for is, well, is the water level falling at this rate? Is it falling at that rate? And the answer is, no it is not, right? Why not? Because negative. Why did we introduce a negative? We introduced it way over here, right? Because the volume is getting smaller, okay? Now the thing is, the height's also getting smaller, but we've already accounted for that with the word falling, okay? So you do have to be careful with your signs here, right? Up, down, decreasing, increasing. It matters when you're considering your derivatives, right? So I have my negative here, right? But when I write this sentence, falling takes the place of the negative, okay? This is a much better way to do it, by the way. the introduction of units and the accounting for the sign. It's a much better way to do it in a sentence rather than to go from this line and say, I've read this before, I've seen this before. People say this. Okay, so units magically appear and negatives magically disappear just because we want them to, right? This is bad. Don't do that. There is no equality between these two lines, but I can draw this conclusion from this equation. Does that make sense? It's a communication thing. It's minor, isn't it? It's not the maths, but it's about communication, which is very important. So there you go. Now, one last thing. When I first became a maths teacher and I was a student teacher, I was really amazed I was like, how hard can it be to be a maths teacher? You just get up and you tell, like, there's steps you have to go through, so you show people how to do it, and then they just go replicate the process you went through. It's easy, right? And I would do that, and I would give a test, and then students would get questions wrong, questions that I'd actually shown them, like specifically how to do that, and I puzzled over why that was. What I learned, one of the important things, if you ever have to teach anyone this kind of thing, or anything, you should learn this. You can't just show people how to do something. You also have to anticipate how they're going to do it wrong and tell them not to, okay? So I will show you a kind of error, which I've seen over and over again, just like this one, except worse, which is about a misunderstanding of the way rates of change works, okay? And hopefully we'll explain why I spent so much time laboring over this, okay? Let's come back a little bit. When I started off, I drew this diagram, right? And basically what I was trying to do was I was trying to account for all of the information that was provided in the question, okay? Put that on there and then start working with it, okay? Now, a very, very common thing to do is, at these points here, I can say, well, look, I know what the height is supposed to be, right? It's supposed to be b on 2, right? So then I can work out what x is supposed to be, and I can sub them in here. I can know what the volume of the water is supposed to be. Namely, I think if that's going to be b on 2, it looks like it'll be ALB on 4, I think. I think that's about right, isn't it? Okay. And students get to this point and then they think, okay, no problems, now I need to differentiate. And then they run into a brick wall. What's the brick wall? You can't differentiate that. And the reason why you guys can obviously see that is because they're all constants. And that's obvious to you. Let me tell you something. It's not obvious to someone who, number 1, has not done this, number 2, is in a hurry, number 3 is under exam pressure, and all they see is letters and numbers, right? They're like, sure, let's differentiate with respect to, and then they just pick something, right? And then they just proceed from there and wonder why things have gone wrong. Okay, and I've actually seen a few of you get muddled up between your constants and your variables. It's all in your setup. Right? The maths is not hard. It's like, whoa, wow, I can differentiate this. Well done, guys. You know, what do you want, a medal? Okay, now that's not hard. But setting it up properly is. Okay? So you wouldn't believe the number of times I've seen students do this and then just wonder, so why have I got this wrong? Why isn't it giving me the answer? It's a misunderstanding of the way rates work and the way all of these relate to each other.